Students, you are welcome to today's teaching. I am your friend and your teacher, Muotoh Chinenye from the Department of Mathematics in St. Charles College, Onitsha, Anambra State. Today, I'll be taking you on a subject called Further Mathematics, and our topic for today is vectors in two dimensions. Sit back and relax, because by the end of this lesson, to distinguish between vector and scalar quantities using examples and their standard units. You should also be able to add and subtract vectors. You should also be able to solve problems on scalar multiplication of vectors. The contents of this lesson are: you have to know the representation of vectors, definition of terms of vectors, addition of vectors using either the parallelogram law or the triangle law. Also look at subtraction of vectors, components of vectors, and the scalar multiplication. Your previous knowledge should be that you have learned polygon, their properties, and straight line. With this, we are going to do well in this topic. Let's go to the topic proper. We'll be looking at scalar, or what we call scalar quantities. And what are scalar quantities? Scalar quantities are quantities with only size or magnitude. When a quantity has only size or magnitude, it is called a scalar quantity. And from the picture you are seeing on the screen, some of the examples we have there are: you have the length, the area, volume, temperature, mass, time, and so on. And their respective standard units are attached to them. We go to the next one, of vector quantities. And vector quantities are quantities that have both the size, or you call it the magnitude. The magnitude is same as the number. It has the size and the direction. It has two things: the size and the direction. That is what makes it a vector, and that is what differentiates it from a scalar. And some of the examples of vectors are, from the pictures you are seeing, are velocity, because it's a vector, it's a speed with direction. You have acceleration, you also have force and displacement. All these I have mentioned have both the size and the direction which they are moving to. Next aspect, which is representing vectors. It is very important you note that there are ways we represent our vectors, and with this, it differentiates them from ordinary letters. Take, for instance, the first one here is using an arrow. Whenever you are representing a vector, we put an arrow at the top of that vector. The arrow there shows the direction, and the arrow has 2 points. It has the tail, and from what we have here, the tail there is P, and it has the head. The head there is Q. And with this P and Q, the vector is named vector PQ, because with this naming, it means that it started the movement from P and ended at Q. That is the first arrangement. Then we go to the representation of vector, which is we represent vector also in a bold typeface. That means you thicken the letter, you double the letter, the font size will be doubled. Then when it is bolded, it is done in a bold typeface. Example, vector A, for you to write vector, you don't just write A as an ordinary letter A. You thicken the font, and when you thicken it is represented in a bold typeface. Then we also have vectors represented by putting a bar. A bar is just like a straight line, which you draw either on top of the vector, or you draw it at beneath the vector. So when you represent this vector in this form, someone that sees it can easily say that this is a vector. Now, for the sake of this lesson, we are going to only use both typeface and the arrow in our representations of a vector. Bear with me. Then we go to another interesting aspect, which we call definition of terms. We need to know some of the terms we make use of in this concept. And one of the terms there is equal or equivalent vector. Then in equal or equivalent vector, this vector, or when two vectors are said to be equal, it means that they have the same size. they share the same size or magnitude, and they move in the same direction, but they will not meet together. So when they share the same size, just like you are seeing it on the screen, you have a vector, and the first vector is named AB. It moves from A to B, and the size of that vector is 5. Then the second vector is named vector PQ. It moves from P and stops at Q, and the same size is 5. So with this, you have seen that these two vectors are the same. Then we go to the then the next one is zero vector. A zero vector does not have a specific direction and a length. An example is seen on the screen. Then the next is column vector. From the word column is in a vertical form. So any vector that is in a vertical form is represented as a column vector. But remember, it is not the same thing as a fraction. Just like you have vector xy cannot be the same as vector x divided by y. No, because when you do that, it's no longer a vector. Then the next one is row. The word row is in a horizontal form. So when a vector is in a horizontal form, it is called a row vector. Example, you are seeing it on the screen. Next time is the magnitude. Very importantly, the magnitude or the modulus of a vector. And for magnitude, we use slash, 2 lines to represent it, or double 2 lines. We use that to represent our modulus or a magnitude of a vector. Just the magnitude or the modulus is just the size of that particular vector. Then the next is negative or opposite vector. For opposite vector, you see when two vectors are in opposite forms, the word opposite, they don't move in the same directions. So for opposite vectors, they move in different directions. One goes up and one comes down. But the important thing there is that the sizes are the same. They don't have different sizes. Example, if you have vector AB as A, then vector BA is minus A. They take a negative value. If vector AB is 5, vector BA, which is the negative of vector AB, will also be minus 5. Very importantly, you have to note it down. Next aspect is position vector. Position vector is a vector that have the same origin. When two or more vectors are sharing the same origin, O, it is called a position vector. Example, vector OX, which moves from O to X, is the same thing as vector X. And vector OY is the same thing as vector Y. And vector OZ is also the same as vector Z. And you see that these vectors are moving on the same directions and also started at a particular point, which is point O, the origin. Then in example 2, you have vector OX, vector OY, and vector XY. If you look at that vector XY moved from X and entered the direction at Y. With this, it is not a position vector because it did not start from O. But vector OX and vector OY are position vectors since they both started from the point of origin, which is O. Then the unit vector. We usually represent unit vector A with a cap. When you put a cap on top of a vector, it is called a unit vector. And for this unit vector, when a vector moves in the x direction, which you will see as you continue in this lesson, when a vector moves in x direction, it is I vector. When it moves in y direction, y is the vertical direction, we note it as j vector. Then we go to the next one, which is resultant or sum or addition of vectors. For sum or addition of vectors, it is just the same as adding vectors. So when you are told to find the resultant of a vector, what it simply means is that you should find the addition or the summation of those given vectors. Then let's look at resultant of vectors or addition of vectors. There are two laws we use, the triangle law and the parallelogram law. For the triangle law, it is something as a tail to head method. Then let's take a look at this. Supposing one wants to make a movement from A to C, it is named vector AC. This vector AC is the same thing as when you move from A to B, that is vector AB, and then from B to C, that is vector BC, as seen on the diagram. What it means is that vector AC is our targeted vector. That means you want to move from A and stop at C. So for you to move from A and stop at C, which I call the targeted vector, and this targeted vector is also the resultant vector. How do you get this resultant vector? It is the same as when you move from A to B, then you bring it down again from B to C. You see, with this movement, you ended your journey at that particular point, C. So with this, we can say that vector AC is equal to vector AB plus vector BC, and that is the resultant of this particular vector. Note also that vectors are commutative. The word commutative means they are the same, irrespective of the ordering. Vector AB is this plus vector BC is the same thing as vector BC plus vector AB. The word commutative means they are the same, irrespective of the ordering. Vectors are also associative. The word associative also is the same as when you have three vectors, you want to add them. In adding them, vector A plus vector B plus C is the same thing as vector A plus B in brackets plus C. Okay, we go to the next one. And the next one there is, okay, let's look at the example on triangle law. In that question, we are given a polygon, and it is a four-sided polygon. And the question says, find the resultant. And the resultant there is vector AB, as the question required. It does not mean that it cannot be any vector, but the question made it that it should be vector AB, which is the resultant. Now, to get this vector AB, which is the resultant, we are going to resolve this polygon, this four-sided polygon, into triangles. So if we are resolving it into triangles, the first triangle we are going to have there is triangle ACD. In triangle ACD, our targeted vector at that point is how to make a movement from A and stop at D. So that is vector AD. For us to make a movement from A and stop at D, that is vector AD, it is the same as moving from A to C. When you stop at C, then you move also from C to D. With that, vector AD is equal to vector AC plus vector CD. And when you add them together, since vector AC is equal to A and vector CD is equal to B, then vector AD is equal to A plus vector B. Then secondly, in the next triangle, we have triangle ADB. With this triangle ADB, we now end it at finding the resultant, which is the question itself. Now, to get the resultant, which is vector AB, what do we do? What we simply do there is, for us to get this vector AB, which is the resultant, we move from A and stop at D, and then move from D again and stop at B. So for us to move from A to D, it is called vector AD. For us to move from D to B, it is called vector DB. In that case, vector AB, which is the resultant R, is equal to vector AD plus vector DB. And remember, vector AD as solved is already given as A plus B. So when you add this A plus B to the vector DB, and vector DB is C, when you add them together, the resultant, as asked in the question, will now become vector A plus vector B plus vector C. And that gives us the answer. We go to the next law is the parallelogram law. And for two vectors to have the same point, for them to have the same point, and in that case, they are in a parallelogram form, we use parallelogram law. But the summary of it is that what triangle law can do for you, parallelogram law also does it for you. So I advise you, my students, to always make use of your triangle law because it's simpler while using. Now, having understood what I did or what I taught you, now get me using this polygon as seen on the screen, Find for me vector AE. If you state each step clearly, it attracts more marks. Use the triangle, resolve it using your triangle law. When you resolve it using your triangle law, you can easily get your vector AE. Okay. Next one then is subtraction of two vectors. Now, when two vectors are subtracted, it means you are adding a negative vector to another vector. When you do that, it is called a subtraction of a vector. Let's go to calculations proper. In the diagram, you are asked to use the diagram of triangle ABC and show how you can make your movements from 1, C to B, that is vector CB, 2, C to A, that is vector CA, and 3, A to C, that is vector AC. Then let's go to the first one. C to B, which is something as vector CB, means that you are going to start your movement from C. Remember, C to B means you move from C and stop at B. So for you to make this movement, you start from C and get to A. Then C to A is vector CA. Then when you stop at that point, you also move from A to B, and that is vector AB. So in that case, vector CB is equal to vector CA plus vector AB. Now also note that vector CA is the same thing as negative of vector AC, as I have told you about negative vectors. For negative vector, vector CA is the same thing as negative of vector AC, because they have the same direction, but they have the same size, but different directions. In that case, vector CB is equal to minus vector AC plus vector AB, and that gives us the answer. Then the next one there, which is number 2, is from C to A. For us to move from C and stop at A, it is called vector CA. For us to make such movement, we begin our movement from C and stop at B, which is CB, vector CB, and also move from B and stop at A, which is named vector BA. So for we to get vector CA as asked, it is the same as vector CB plus vector BA. Remember, vector BA is the negative of minus vector AB, as I have told you about opposite vectors. So simply, vector CA is equal to vector CB. The plus, we multiply the minus inside the bracket, it gives us minus, then we have vector AB. So in that case, vector CA is equal to vector CB minus vector AB, and that is our answer. Is vector AC, which is moving from A and stopping at C. So how do we move from A and stop at C? We have to first start our movement from A and stop at B, and then move from B and stop at C. In that case, vector AC is equal to vector AB plus vector BC. But you also remember that vector BC is the negative of, is the same as minus vector CB as a negative vector. So in that case, vector AC is equal to vector AB minus vector CB. Alternatively, you can simply do it this way. Since we have known the value of vector CA, and our vector CA as solved already is vector CB minus vector AB. So for us to get vector AC, which you know is the negative of vector CA, what you can simply do is vector AC, which is what the question said, is equal to minus vector CA, which is vector AC is equal to minus in brackets, our vector CA is equal to vector CB minus vector AB. So when you expand it with the minus sign, vector AC will simply give us minus vector CB plus vector AB, which is also the same as vector AB minus vector CB. And that gives us the answer to that question. I hope you are still there with me. Then we have components of a vector as another thing we are discussing. For a vector in a component form, it is a vector that has both the I and j units. And for I, its coefficient is x. For j, its coefficient is y. So when a vector is represented in a form that it has I and j units attached to them, we call it a component vector, or a vector in a component form. Then this vector in a component form can also be expressed as a column vector, which we have discussed. A column vector is a vector in a vertical form. This component vector can also be expressed as a row vector. So either of these expressions are also showing a component vector. Let's look at examples of component vector. We have the first example, there is vector A is the same equal to 3i plus 4j. 3 there is the coefficient of I, and 4 there is the coefficient of j. Then we have another way you can express vector, component vector, as vector B is equal to 2 and minus 3 as a row vector. You also have vector C is equal to minus 1 and 4 as a component vector. Now with these are vectors expressed in component forms. Then let's go to scalar multiplication of vectors. When you hear scalar multiplication, scalar is a quantity without direction. Then we are looking at how to multiply a number with a vector. So when you are multiplying a number with a vector, it is called a scalar multiplication of vectors. Examples or questions. Then given a vector A equal to 3i plus 4j, this is a component vector. Then we are asked to find 2 vector A, 2 minus vector A, 3, 1 over 3 vector A. Solution: for us to get 2 vector A, what you simply do is to multiply that 2, which is a scalar or a number, with the vector A. Now for us to do that, we are going to have 2 in brackets. Our vector A as given is 3i plus 4j. So we have 2, by expanding, we have 2 vector A is equal to 2 times 3i will give us 6i, and 2 times 4j will give us 8j. So 2 vector A is the same as 6i plus 8j as our answer. Then number 2, minus vector A. The scalar there is minus 1. So we are going to multiply the vector with minus sign or minus 1 into 3i plus 4j. Remember, our vector A is given as 3i plus 4j. So when you multiply this with minus sign, or you can also multiply it with minus 1, but we are multiplying with minus sign. So in that case, minus 2 times 3i to give us minus 3i. Then minus 3 times plus 4j to give us minus 4j. And what it simply means is that minus vector A is equal to minus 3i minus 4j as our answer. Then the next one is 1 over 3 vector A. We are going to use the scalar 1 over 3 to multiply the vector A, which is 3i plus 4j. Then multiplying through 1 over 3 times 3i will give us 3 over 3i. Then 1 over 3 times 4j will give us 4 over 3j. When you simplify, you are going to have 1i, which is something as I, plus 1 whole number, 1 over 3j as our answer. Okay, go to questions on scalar multiplication as it continues. Second example is, we are given vector AB, and this vector AB is in a column form. We have minus 3 and 4, minus 4. And we are asked to find vector BA. And number 2, we are asked to find 2 vector AB. Solution: if you are looking for vector BA is not given in the question. What the question gave us is vector AB as minus 3 and minus 4 in a column form. So for me to find vector BA, you have to know that vector BA is the same thing as minus vector AB as a negative vector. Note, it is very important. So with this, vector BA is equal to minus, in bracket, our vector AB is minus 3i minus 4. Then when you multiply through by minus, we are going to have 3 and 4 as our answer for the question of vector BA. Then the next one is 2 vector AB. We are going to use 2 to multiply vector AB. So we put 2 before, then we multiply it with minus 3 and minus 4. Then 2 times minus 3 will give us minus 6, And 2 times minus 4 will also give us minus 8. Then we go to another example. We have finally come to the end of this lesson. Then answer the following questions and submit to me. Number 1 is, look at the direction of that vector and name it. 2, also look at the direction and also name that particular vector. Then in number 2, you are given a triangle with their respective directions. Use the addition and subtraction to show how you can move from C to E, 2, B to C, 3, A to C, and 4, A to B. Use diagrams. When you use diagrams correctly, it attracts more marks. Then number 3, we have in triangle XYZ, you are given vector XY as A, vector YZ as B. Then you are asked to find A, Roman figure 1, vector ZX, 2, vector XZ. Then B, if M is the midpoint, midpoint is the middle point of the line XZ. So at the line XZ, there is a middle point there. It is represented as M. Then when we have that, use it to find vector MX and vector YM and other remaining questions on this. Solve them and kindly submit to the WhatsApp number 08069 46 71 and 27. Thank you for listening. Bye-bye.